Hey, D. Dykstra here. Another great video for you on derivatives of bases other than e. Okay, so if we're going to take a derivative of something with respect to e, then there was e to the x and e to the u and how we dealt with those. Well, now we're going to deal with some bases that are not e. So let's look at the rules. Basically, here's some format for you. The derivative, d dx, the derivative of a to the x, where a is a constant, like 2 or 4 or 5 or something, is equal to ln of that a value times a to the x. All right, well, what happens if that a to the x is something a little more complicated, maybe like a 3x or an x squared, or there's something else happening with that x? Well, then we're going to use this format. The d dx of a to some u is equal to ln of a, right? Same a value. We're not changing the base value. It's ln of the a value times a to the u, which is what we had originally, times u prime, or the derivative of with respect to the u. Okay, the derivative of u. If we have the derivative with respect to x of log a of x, where the base is a, and then we have some x value, that will equal 1 over ln of a times x, all in the denominator. All right, it's all in the denominator. All right, so now, one last one, the derivative with respect to x of log a of u. So let's say now in here, there's something a little bit more complicated, maybe a 3x or 2x plus 5. Something else is going on there. Then what we'll have, or maybe a trig function, which we'll show you in a second, is 1 over ln of a times the u value in the denominator, and now in the numerator we're going to put times u prime. Okay, so maybe there's another value here. We would end up multiplying those together. All right, well, let's look at some examples then of what we got. So here's an example of y equal 2 to the x. So what is the derivative of y equal 2 to the x? Well, y prime is equal to ln 2, right? Remember the ln based on the 2, times 2 to the x. All right, what if we have y equal 2 to the 3x? Well, here's our u value, right? Here's a u situation. So we're going to get y prime is equal to ln 2, right? There's the base, ln 2, times e to the u, which was 2 to the 3x, and then the derivative of 3x is 3. So we can always rewrite that as 3 ln 2 times 2 to the 3x. So we bring that 3 out front. Now, one thing you want to make sure is that you do not multiply the 3 and the 2 together and make it 6 times 3, or to the 3x power. That would not be right, because 3 does not have an x associated with it. If 3 did have an x, then and if we were the same base, we could multiply, which means we would be adding the exponents. But in this case, we don't have that situation. All right? We would have to rewrite 3 in terms of sum 2 and then add exponents, but we cannot multiply them together. So that's a thing to think about. All right. Example number 4 is when we have y equal log base 10 of x. All right, so we go to find that derivative. Again, it's y prime is equal to 1 over ln of 10 times the x. All right, so pretty straightforward. These rules, definitions of how to find the derivative. We get y equals log base 10 of cosine of x. Well, now we've got something a little bit more interesting here. Instead of just an x, we want to count this as our u. So we'll go y prime is equal to 1 over ln of 10, right? Use the same base. We didn't change the base. Times the cosine of x. And now we want to figure out, well, what's the derivative of cosine? Because it's 1 over ln of a times u in the denominator times u prime in the numerator. So what is the derivative of cosine? Negative sine. So now we get all multiplied, and so what we can do is we can rewrite this then as negative sine of x ln of 10 cosine x. And we might even simplify it further. We could say negative tangent of ln, tangent times 1 over ln of 10. So we could do that as well. But, leaving it as negative sine of x over cosine of x is fine. All right, so there you go. That is the basics of derivatives of bases other than e. Hope you had a great time. Thanks again. Keep it mathy. D. Dykstra signing off. Have a great day. We'll talk to you soon. Bye.